Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So I'm going to first start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1,000. Now, if I simplify what's in the parentheses, 1 plus 1 plus 1 plus 1, that's 4. So I have 5 to the power of x times 4 is equal to 1,000. Now I can divide both sides by 4. So then these two cancel out, and now I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. Now, 250, I can rewrite this as 25 times 10. So I have 5 to the power of x is equal to 25 times 10. And 25, that's the same thing as 5 squared. So now I have 5 to the power of x is equal to 5 squared times 10. Now what I'm going to do is I'm going to take the log on both sides. So now I have log of 5 to the power of x is equal to log 5 squared times 10. And now an important rule to note down is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b in this case. So I can simply move x to the front. So now I'm going to have x times log 5 is equal to log of 5 squared times 10. Now, we obviously want to find the value of x, so to do that, we're going to have to isolate it. And to isolate x, we're going to have to get rid of this log 5 by dividing both sides by log 5. So then these two log 5s cancel out, and then I get x is equal to log 5 squared times 10 over log 5. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 5 squared times 10, that's going to equal log 5 squared plus log 10. Now I have this over log 5. Now remember how if I have something in the form log AB, I can move this to the front. So now I have x is equal to 2 log 5 plus log 10 over log 5. And log 10 is equal to 1. So I have x is equal to 2 log 5 over log 5 plus 1 over log 5. These two cancel out, so I get x is equal to 2 plus 1 over log 5. Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to start by taking the log on both sides. So now I have log of 4 to the power of x is equal to log of 40. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 4 to the power of x, and I can move x to the front. So now I'm going to have x times log 4 is equal to log 40. Now I'm going to go ahead and divide both sides by log 4 so we can isolate x. So then these two log 4s cancel out, and I'm going to be left with x is equal to log 40 over log 4. Now we can rewrite log 40 as log of 4 times 10. And if I have something in the form log of a times b, this is equal to log a plus log of b. So log 4 times 10, that's going to equal log of 4 plus log of 10 over log 4. And if you guys already know, log 10, that's actually equal to 1. So I have x is equal to log 4 plus 1 over log 4. Now, I can rewrite this as log 4 over log 4 plus 1 over log 4. Now log 4 and log 4, these two cancel out. So I have x is equal to 1 plus 1 over log 4. Now log 4, this is equal to 0.602. So I get x is equal to 1 plus 1 over 0.602. And 1 divided by 0.602 is 1.66. So 1 plus 1.66 is 2.66. Alright, so in this problem, I have x to the power of 2 minus x to the power of 3 is equal to 12. So I'm going to first start by rewriting this as negative x to the power of 3 plus x to the power of 2 is equal to 12. And from here, I'm going to multiply both sides by negative 1. So now I get x to the power of 3 minus x to the power of 2 is equal to negative 12. And now, finally, I can add 12 on both sides. So now I get x to the power of 3 minus x to the power of 2 plus 12 is equal to 0. Now I'm going to rewrite 12 as 8 plus 4. And I'm going to actually move some terms around. I'm going to move 8 next to 8 to the power of 3. So if x to the power of 3 plus 8 minus x squared plus 4 is equal to 0. And 8 is the same thing as 2 to the power of 3. 4 is the same thing as 2 squared. If I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. And a squared plus b squared is equal to, a squared minus b squared is equal to a plus b times a minus b. So in this case, I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 times x minus 2 is equal to 0. From here, I can factor out x plus 2. So I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 is equal to 0. And if I simplify this, I get x plus 2 times x squared minus 3x plus 2 is equal to 0. Sorry, minus 3x plus 6 is equal to 0. Now, I get two equations from this. I get x plus 2 is equal to 0, and I get x squared minus 3x plus 6 is equal to 0. So for x plus 2 equals 0, x is obviously equal to negative 2. And for x squared minus 3x plus 6 equals 0, we have to use the quadratic formula. And I'm not going to waste your guys' time by actually plugging these into the quadratic formula, but the final answer is that it's actually going to be rejected because the square root is going to be negative, and you can't take the negative of square root. So my only answer is x equals negative 2. Alright, so in this video, I'm going to solve the equation 5 to the power of x plus 5 to the power of x is equal to 7. So, to solve this, I'm going to first start by factoring out 5 to the power of x. So I get 5 to the power of x times 1 plus 1 is equal to 7. And 1 plus 1 is 2, so I get 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2. So these two cancel out. And I get 5 to the power of x is equal to 7 over 2. Now I'm going to take the log on both sides. So I get log 5 to the power of x is equal to log 7 over 2. And if I have something in the form log a to the power of b, this is equal to b times log a. So in this case, I can move x to the front. So I get x times log 5 is equal to log of 7 over 2. Now we want to isolate x, so I'm going to divide both sides by log 5. So now these two cancel out, and I get x is equal to log of 7 over 2 over log 5. Now this turns into log of 7 minus log 2 over log 5. Which is equal to 0.8451 minus 0.3010 over 0.6990. And this is equal to 0.7784. So this is my answer.